My name is Jonsson, and my position is Chief Firearms Expert at Solution Engineering. And my background is I have both a bachelor's and master's in architecture. Well, my architecture background specifically is in what was known as design integration. I have a master's of architecture in that. And that had a lot to do with how do you fit everything together. In architecture, there's a lot of 3D thinking, structures, materials, and all of those skills actually translate very well to the firearms industry. I own my own company for about a decade now, and we do products for the consumer market and also do design work for OEMs, essentially other companies under their brand. They'll come to us, and I do design work for various conversions, parts, whatever they may need in the firearms industry. When a gun is fired, user pulls the trigger and a mechanism, usually a firing pin, impacts a primer, which is a small packet of explosives that sets off the main charge of gunpowder, which goes from a solid, it almost instantly turns into a gas, which creates a lot of pressure. That pressure pushes the bullet on the end of the cartridge down the barrel, and ultimately the bullet will exit the barrel. When the gas exits the barrel, there's still a lot of energy in it, and a lot of times you'll see that as actually a fireball. It's distracting to the user, can blind them temporarily if it's bright enough. Depending on the situation, it could be seen by other people, and generally it's energy that has no purpose. And that's wasted energy. Besides a flash, the energy of a gunshot also creates a pressure wave. It's uncorked pressure coming out the end of the barrel, and what we know as a pressure wave is essentially what we would consider sound. The sound can be distracting, can be painful, it can actually be dangerous to your hearing if it's powerful enough. But the positive aspects of the pressure wave are there's untapped potential energy there, which can be used either to help control the muzzle of the gun by pushing it down, or even can be used to cycle the action of the gun by redirecting some of that energy backwards into the system. The four types of devices used to control muzzle energy are a flash hider, sometimes called a flash suppressor, a muzzle brake, a linear compensator, and a suppressor, also often known as a silencer. A flash hider, by its name, actually hides the flash, or rather suppresses it. What it does is control the combustion rate and basically moves the gas profile out of the ignition point, so you can reduce or completely eliminate the flash from a bullet exiting and the gas exiting the barrel. A muzzle brake uses slots or holes to basically control where that energy is being expelled, and it can be used to reduce the felt recoil of the gun. It's actually pulling the gun forward a bit. It can also be used by jetting it upwards to actually push the muzzle down to counteract muzzle rise, which is common in most firearms. Well, linear compensator is essentially a overboard device on the end of the muzzle. It's larger than the bore that the bullet comes out of, and it helps throw the sound and flash forward so it's not as distracting to the user, but it doesn't eliminate it or suppress it. A suppressor in its simplest form is like the muffler on a car. It's a large chamber with multiple walls in it, and they're perforated by a hole, all of them, that the bullet moves through. And as the bullet uncorks from the barrel and the gas comes out, as opposed to just going out into the atmosphere where it creates a pressure wave, it's given time and space to cool down, to lower from the ignition point so you don't get flash, and by cooling down and having space to expand, it actually reduces the overall pressure wave coming out. It actually makes things quieter than it normally would. A suppressor cannot, for all practical purposes, make a gun silent, and the term silencer has been replaced more with the term suppressor for that very reason. A gun is never going to be silent. It will be less loud. Well, you can see that there are four different types of muzzle devices. There's also no muzzle device. The Thompson M1 is a good example of that, and you can actually see by the combination of the ergonomics and the fact there's simply nothing to work with the energy, you get a lot of muzzle blast, a lot of muzzle rise. So that's a good example of how a brake could counteract that. My role in an investigator is, if something goes wrong with a firearm, to try and understand why and how. Muzzle devices, the most common failure would honestly be that the wrong muzzle device was used. Typically there's common thread patterns used on a muzzle device, but it is possible, because of the various ways they're put on different barrels, that you could put a muzzle device that the bore hole is not large enough for a bullet to actually pass through it from that firearm. Heard it, seen it. Well, investigating a gun incident would really be breaking it down into 3 potential failure points. The firearm itself, if there was a mechanical failure, or even the ammunition was incorrect, a user not using the firearm properly, whether that was how they assembled it, how they're operating it, how they're safely or not safely handling it. And in some instances it could be the environment too, where say water or mud or an obstruction somehow causes the firearm to act in a way it wasn't intended to, because the mechanism itself isn't functioning properly. And also could be all 3 or a combination of the 3. Somebody should come to solution engineering because it's not just the engineering part, but it's understanding the human factors involved, the environment, the whole bigger picture of the situation that led to whatever failed.